I hate pink. That's it. That's the whole thing. Cool. That's it. That didn't seem very fun. But here we go. Let's chalk it. Yeah, right. All right. We have a flagpole that sits at a right angle to the horizon, and it's on a slope that makes an angle of 12 degrees with the horizontal. Let's draw that first. Can we all agree that the horizon, regardless of where you feel about the shape of the Earth, is flat? Did you know that that's where it was going? Or were you laughing about another joke that I told another day? Okay, cool. So here's a horizontal. And on this horizontal, there's a hill. There's a hill. And what's the slope of that hill? 12 degrees. Okay, so we have a 12-degree incline. All right, and then on this hill is growing a what? Oh, it's not growing. It's a flagpole. That'd be weird if it was growing. Whoops. I mean, maybe it'd be weird. Maybe it wouldn't be weird. I don't know. But flagpoles are gray, so we'll go ahead and use that. Can we assume that it's just growing like out of, like, not growing again, it's not a tree. Can I just draw it here? Okay, so there's a flagpole. Now, it needs to be drawn elsewhere because I read the next part of the problem. Probably should read the whole problem before I start drawing. That's a me problem. What did I draw wrong? The shadow goes where? Up the hill. I don't want to have to extend the hill. I'm going to put my flagpole here instead. And then the shadow falls on the ground to where? How far up this hill? 16. Now, okay, so that is 16 right there. Okay. And then what else do we know? Points directly up the slope. The angle of elevation from the tip of the shadow to the sun. So I don't have a sun here, but I can make one. Okay, there's the sun. It is beautiful. And if we were to point at from the tip of the shadow up to the sun, like that, and I'm only going to go to here, is that pointing at the sun? Okay, here's where, if you're going to get the problem wrong, it's going to happen. What do you want me to put as this angle? Is that angle 20? If we're drawing an angle of elevation or depression, it's always drawn from the what? So right now, if I said, look 90 degrees up, which way are you looking? Like, okay, what about look 0 degrees? Everybody looked the same way, mostly. I can't tell exactly what you're doing, Christina, just so you know, but that's okay. So that's fair. Look at the 0 degrees from where you're at. Is everybody looking straight forward? Is that the default to how we measure angles? So if I were to sneak in a little tiny horizontal right here, just so we have it, and I can even do it larger than that, actually. I don't know why I need to make it small. Can I sneak in a horizontal right here? And then now I have a couple things. I have parallel lines, which maybe we'll take advantage of. And then I can really clearly see my angle of elevation. The angle of elevation is always from the horizontal, which means this angle is what? 20 degrees. What's this angle? 90. And if we wanted it, can we find this angle? 70. How'd you do that, Red? Yeah. Okay. We are getting close to working this out. I also know that that is 90 degrees here. Any other angles that we know? I think I know this angle. Why 12? We have alternate interiors, parallel lines, and I'm going to make them really clear. That parallel line and this parallel line cut by a transversal, alternate sides of this transversal, and on the inside, that's 12 degrees there. Now, whether I'd really write all this 12 or not, I don't know, but I've made another fatal flaw or fatal mistake that I hope isn't fatal, because a minute ago, I stopped drawing and I said I didn't read the problem, and then I immediately started drawing again. Do you think I had enough time to read the rest of the problem? So before I commit to going too crazy, let's just check. So I have all those. I need a triangle to represent the situation. Show the known quantities on the triangle and use a variable to indicate the height of the flagpole. So we've got this out. Is this picture kind of convoluted? Does it, is there more here than I need? Like, has it been, I'm trying to think of, Karina, I need your help. Define convoluted. There we go. Is this picture gosh, you're good. Unnecessarily complicated. Yeah, what triangle do I really care about? Just this. Can I draw just that? Okay, so let's draw just that. That's how I always draw my A. What do you mean no? Okay, what's this angle? And this big angle. 32. And let's see, this must be 78. Yeah, that's right. How did I get 78, Lay? What do we know all three of those angles in my 3 angle have to add up to? Perfect. Yep. Okay, so now we have this. Anything else that we have on this triangle? 16 right here. And I need some value for this. Can we all just look at something really quick and you guys tell me if you understand why this bugs me? Could I do this if I want? Why is that annoying? Does it annoy anybody else? Somebody in, so it's not that it's capital. Somebody in here is going to be crazy like I am, though. Yeah. What, like, we could do this, and this is allowed, but is this an X direction? Like, that bugs me. I don't care if you call it X, you're right, and it's fine. Y is a more natural choice, or there's even a more natural choice, since we're looking for the height. H. Okay. The rest of the problem, I don't know, is crazy hard. The drawing of it is definitely the most challenging. Do we need to finish this problem? Is this a law of science problem? Yeah. How do you know? Yes, or angle, angle, side, or angle, side, angle. Either one works, but you're right. It's not SAS. It's not ass. We're good. Cool. Ace or asa is what we're given. Okay. Awesome. Last one. Or was that last one? 50. Oh, they give me a picture on 50. All right, here's the deal. I'm going to let you guys pick your groups today. For now, we're not going to do this every day. 3, 6, 9. There's a group of 2 or 2 groups of 4. What do you guys think? So 3 groups with 2 groups of 4. Well, we have 11 people, which is why it makes it weird. I want 3 people in groups. 3 groups of 3 and a group of 2. Okay. Self-organize into 3 groups of 3 and a group of 2. I'll give you 60 seconds or else I'm just going to go random. I can see the answer. I don't care that you can see the answer. You guys are going to go work this problem up on the boards. Pick a board, pick your partners. I'm going to let it ride this time. Absolutely. Thank you. All right, do it to it. Anybody want to work up on this board so that Basil can hear you working? Okay. So here it is. I will give you this. You guys just make sure, when you're talking, please make sure that this is here. Try to talk your ideas out. Whoever's holding it, don't just blindly write. I think that either of you could do that. Have you written on this before?
A little bit, yes.
Okay, just remember, never look down at this while you're writing. You're always going to look up at this. Okay. I'm going to move this over just a skosh. Sorry. Can you lift the pen for just a second? No, you're good. Just to get it as much out of the way as we can.
Probably broke something. Oh, does something actually break? Yeah. I was actually doing like it's plastic.
Oh, you're good. All right.
Okay. So what we're gonna first do is let me find myself. Okay. Let's first draw the triangle for ourselves. But we have the triangle already. Let's just draw the triangle for ourselves. Okay. So why did the picture go away?
I gotta freeze that screen so everybody can see it. I'm sorry.
Sorry.
No, you're good. That's my bad. Alt tab, and then I'm just gonna freeze it. And I'm gonna freeze this one, and then you can sneak out. You can change it now.
All right, go. Okay. Solid. Okay, so let me go back. Sorry, Hazel. We're just gonna draw it. Yes. I have to look at the book for this. Why is my T missing a side? Okay, not that bad, not that bad. We'll label it. Okay, we'll label it. So one, this side is 100 meters. Hold on. Okay, this is 100 meters. 100 m. And then this angle specifically is 41. 41? Okay. Pause, Hazel. Sorry. Sorry. Okay. Your handwriting sucks. Oh, shut up, Kuna. We can't argue on this. 41. Okay, 41 degrees, Hazel. This specific part. Okay. And then that, we have to draw this part. Okay. So we're gonna draw, I think it's called an auxiliary line, I think. Yes, auxiliary. So this entire thing together is 74. Four? Four, not 8. Shh, I'm looking at two different numbers. I'm getting confuzzled. Okay. The entire, I'm gonna point an arrow out. Actually, no, I'm drawing here. Okay. 74 degrees. And this one, this short specifically, like this one, is 28. Is 28 degrees. We have to figure out. We have to figure out the distance from the gazebo to the dock, which is, so the dock is over here, and the gazebo is over here. What we need to figure out is um is we have, let's see, we need to find the angle for something. Okay, so this is 41. Are we, if this is an auxiliary line, this is straight though. That's not straight. It doesn't look like it. We can figure out that one. What's 74 minus 28? You have a calculator. Let's see. Okay. 46. What? 46. 46? Yes. Okay. That's just, it's not the whole thing, but it's like the short one. It's that one is 46 degrees. So what we need to do is find the distance from the gazebo to the dock. So we have our angle here, a side here, and an angle here. No, we don't. No, we don't have an angle here. Pause. Wait, ignore that. Can we not say that this is 50 of 90 though? No. We can't trust the drawing, remember? Okay, never mind. Let's see. We have a angle but no side. Angle, no side, angle and a side. What we can do, however, is we can figure out what this angle is. What, can I try something? Can I draw something? No. Just tell me what to do. Can you make this a right triangle, not a right triangle? Huh? Can you make them right triangles by drawing a straight auxiliary line? Because then we can figure out what these angles are to figure out the angle of the dock. So if this is 41 and this is 90, 90 minus 41 is 90 minus 40 is 50. 50. Okay, so 49. So this is 49. And then do that, this one. I'm going green out. Okay, so this is 28. Do the right angle thing. And this is 90. 90 minus 28 is 90 minus 20 is 70, and then 70 minus 8 is 62. So this is 62. So we have 180 minus 62 and 49. 180 minus 62. 180 is 118. Okay, hold on. 49 minus 49 is 69. So end up being 69. Yes. So that angle. So this is 69. And now we do, because of that, 180 minus 40. 74. Oh, no.
I don't know if you need it necessarily either, but I don't like that.
Okay.
What do you guys think?
We're finding angle first. This is 46. Like this angle. Yes, it's 46.
And just speak normally, just so you know, you don't have to like just. I just want to make sure that your thoughts are on.
Okay. 69. Okay, I'm gonna do that. Okay. 180 minus 46. 46 minus 49. 69. 69. 65. 65. So this is 65. Now that we have, so now we can do law of sines because we have all our angles and
Can we
a
erase
side
this?
length. No. No. Okay.
Scroll down a little. There you go.
Okay. Say what to do again? Okay, we're doing law of sines. We have, since we're finding a length, this will have to be, it would be 100 meters, 100 over the sine of 69, 9, equals, we can call this the length from the dock to the gazebo. We can just call it L. L, like, over sine of 74. No, 46. 46, not 74. Ignore that. 46. Okay, so which changes to L is equivalent to 100 sine 46 over sine 69. We have to say it all. And what we get for L equals 77.0517. And we're right. Meters. Okay. And because we have the book in front of us, 77 turns out to be correct.
And we have to answer this question as a sentence.
Yes, because it's a word problem. So the length for distance from the gazebo to
another minute or so. There is a group that if you're struggling, I would strongly recommend check out their stuff.
okay, not us.
Is it 65? Am I wrong?
Oh, they can see us. They've been seeing us.
They've been seeing us.
To the dock.
Okay. Can you fix it? That's fine. But like, I have a mistake. You said.
Oh, because 74 then her and we added 74.
Yeah. But I didn't really add it, did I? Not correctly.
You added it.
Did I add it correctly?
I think you added
Gazebo? Yeah. G to D.
Love it. I think they get the same thing.
Okay.
Yay!
We
did it. We did it.
Cool. Will you hit pause on the recording? Very top, there's pause and camera buttons. Like very top, it's in the black next to the selection. Keep going.
Up there.
Right there. Nobody knows who it was. So checking it out from this picture, and looks like we did a bunch of other thinking. That's a different problem. Never mind. Okay, so this picture's gone. I'm going to put it back up here. Nope, still the wrong one. Did I not do it? Weird. I could have swore that I had a picture of it. Okay, so we'll just take this picture. Now, a couple things. There's some good geometry review that we can knock out in here. And I'm not going to copy all the words and stuff, just so you guys know. But I do want to just look at this picture just to make sure that if you're struggling with it, we can make sense of it. Did you guys do this on your homework last night? Okay, so quick question. It's okay if you tried and struggled, but I just want to really highlight. Did I give you guys any additional info here? So if you guys can do it when I have you go up to the boards and stuff, I think you could probably do it at home as well. You need that confidence. Like, you should be there, just so you know. But what are we actually looking for? And I just want to make sure we all have this. Okay, so first things first, an old geometry idea that in my mind, we're trying to find this distance, right? Okay, do we need this angle? I mean, kind of, because we need to get this angle, right? Now, so check this out. Do we have parallel lines running here and here? Are they being transversed by this? Now, big idea here, and I'm going to erase some stuff, but it's a geometry idea that we've used, and Addison remembered it yesterday. I just want to make sure we all have it. This 74 degrees has to be the same as this. Why? Alternate interior. So we can think this way if we want. That's 74. If I take this angle plus this angle plus this angle, what do I know they have to add up to? So let's just do a little bit of thinking here. What's 74 plus 81 add up to? 85 and 40, I guess. So 74 plus 41, just so you guys, in my head, I add the 1 first and get to 75. We all agreed? And then I add 40 more. I think I said 85. I think I misspoke. Sorry. So 75 plus 40 is 115. I think this has to be 65 degrees. And one of your groups, I told you were wrong, but I had a mistake. Do you say how? Okay. I did not realize they were different angles. Okay. Did you say how or did you say ow? Okay. It definitely looked like how, but that's fair. Degrees. Okay. Well, if that's 74 and that's 65, can we find this angle? And let's see. 69 and 70. That's an ugly one to add. 139. Is that right? That's too big. Yeah, 41. Oh, okay. So what's this angle? 26? Got me good. Control Z. Okay, 46. What's this angle? Can we law of sines this problem? 46, or this side, I'm going to call this Z over the sine of 46 equals 100 over the sine of this, and we're done. 77. Cool. Miss Sweet, come around and check those, I believe. All right, let's get a new one. We're going to see how much y'all remember from geometry. Cool. Cool thing is that I actually taught your geometry, so I know exactly what you should remember theoretically. But let's check it. We're going to switch it up today also. Flat ground. Cool. All right. I did not black ground everything, just so you know. I just did the dropper tool, the fill, and then I would normally do it with the background layer because now if I erase something here, it'll be white, but I'll just use a black marker to undo it. All right. So today we are going from memory, and Addison, you don't have to close your book, but I'm going to ask, don't look down at your book to answer questions. Just you're good. Like, you're okay to keep it up. We are going to look at 6.2. And in 6.2, our focus is on the law. Like, we always obey the law. We saw the law of sines last section. There's another one. The law of cosines. Okay. Big moment here. Just thumbs up or thumbs down. I remember hearing this. Not I remember exactly what it is, but I remember talking about the law of cosines. It's okay if not. It's been a couple years. That makes sense. I would assume you guys saw an algebra last year, but I don't know. I'm not sure. Okay. Does anybody feel like you remember the law of cosines? Okay. So we are going to go back up to the board here in just a second, just so you know. But we're going to actually work this out. And we're going to look at a proof of it, but we're going to prove it differently. So I think we probably proved this back in geometry using geometric means, which you may or may not remember that, all that. We, and by we, I mean you, are going to prove the following, but I'm going to give it to you right off the bat. So first thing, we're just going to say two main pieces. We are going to use a law of cosines if the information that we're given is side angle side or side side side. This is law of cosines. When did we use sines? Saw ace, and there's an ambiguous case as well. Indeed. Cool. Can we, just for the record, I'm only okay with the swearing when it's very specific to the math. Cool. Let's not make it think that I'm just being super casual with it. Don't swear, except for saying ass when it's an ambiguous problem. Cool. All right. So let's check it out. I'm going to make a claim, and we're going to sketch this triangle out really quick. and I want you guys to sketch this as well. You will be doing this up on the board, just so you're aware. I'm going to make you guys go try this in groups, but we're going to sketch it out first. And we're going to use some coordinates to help prove this idea. So we are going to put 3 points on this coordinate plane, and we're working quadrant 1 out of convenience. So we have x and we have y, and let's put 3 points on here. I want one of my points to be the nicest place it could possibly be, which means it is where? 0, 0. Here is a point at the origin. We're going to call this A. Okay, we're going to move over. We'll say that this thing goes up to some arbitrary point up here, which we'll call C. And all we know is that it's an ordered pair, x comma y. That's it. All right, and then down here, we'll just go ahead and put somewhere along this axis. I'm trying to make it not a right triangle necessarily. We're going to put point B down here. Where B, and this is going to be super misleading, can you guys tell me what we would name, if I make this a triangle, what we would name the base with the way it's oriented right now? What would this side get named? So this is weird. To be lowercase c, you're right. But instead of saying x comma y, because I don't want it to be the same x, if we all agree that if I started at the origin and I went c units over, because that's the name we call it, we would just say this is the point c comma 0. It's weird, but check it out. If I made a claim that this, and I'll show you, you will get this. Don't write this. We'll go pink for think still. If that's 5, what's this ordered pair? If it's C, what's that ordered pair? That's where it's happening. And it's pretty abstract when we first see it. But does that make sense for everybody? Why we would choose C0. Okay, I'm going to add one more little tiny thing in. I'm going to add a vertical right here. And let's just get a couple other measurements before I cut you loose. What's this side? A. What's this side? B. And then I'm going to do it like this so we can see the whole side. That whole side is C. And can you tell me this distance right here? There's a point that will, so C over B is a good thought. I go from 0, 0. How far to the right do I go according to this? I only go x horizontally. This distance must be x. This distance could be c minus x if we wanted to put it. Like, we can get them all out there. But I think that this is sufficient. Okay, here's what I want you to show. And it comes in 3 flavors. We will have all 3 of them. You guys are just playing around. It's not a super formal proof, just so you know. I just want to see if we can get to it. Show me that this indeed works. So I want you guys, and we'll go up to the boards here in a second. You can show, and you don't have to write the show part in yours necessarily, unless you want to. You're going to do the proof on the board, and then we're going to write the law of sines. I want you to show me that it is in fact true, that if I wanted side A, it is exactly equal to A squared, is how we will get this. What are the 2 sides that aren't A? So B squared plus C squared minus 2, we're going to use the exact same things, BC times the cosine of angle A. I'm going to go one step, and just to help you out, if this is an x, this is the only other distance I think I want us to have. What's this one? It is a height. Is there a better value that we can use? Just like we went from, it's y. Why is it y, or? Okay, I just couldn't, like, it's, yeah, you're good. Cool. So I'm also very hungry to watch your guys' brains. Like, I can tell the brains are just starving right now. So I want you to go show me this is true. That's the only guidance you get. I'm going to give you guys like 5 to 10 minutes. I'm cool with that, if you're cool with that. Do you want the same board? If you're wrong, it's forever memorialized on this video. Okay. Whoever, you guys should switch. I'm cool with it. Sweet.
Okay, we're back.
We are back.
And we are going to show how a squared equals.
Did not think about that component of it. Where did that picture go?
Okay, so let's start off. We're trying to find that a squared equals b squared plus c squared minus 2bc by the cosine of a. So How shall we do this? Christina, stop messing around.
Nope, that's my calculator.
Okay, how do we
Right,
start
apparently
this?
no is the answer.
How do we start this actually?
The answer is yes.
So, how
But you still might want to work on that board. I did not think about that for this.
A squared.
talk a little louder?
A squared.
What?
Okay, let's attempt. So this little part would be. Let's see. How do hold B? Because this obviously we can assume that this is a right triangle, right? We can assume because flat and that's a vertical, so that's right triangle, right? If A squared, right? Because that's the hypotenuse. We have to figure out this length, right?
Mm-hmm. Yes.
Yes.
Okay. So,
However, to be that would be what? C minus X.
yes.
I'm also taking these just in case
Okay.
you happen to look down.
So, well, we've set up the
Yeah,
Pythagorean theorem.
Pythagorean theorem. Hold on, give me a sec.
Sorry.
Minus 2. We have to figure out how it gets to that, right?
Mm-hmm.
We have obviously we need to figure out what.
Is there a geometry expression that spits out a
Why?
squared and a b squared and a c squared somewhere?
Pythagorean theorem.
Just talking that out for
A squared. So that would be
Can you write it?
yes.
You're killing me. Well, it's not c squared, Karina, because we have that thing.
Hold
The up here.
technical difficulties. Please wait.
Leia, I really like that comment. The last thing you said.
Okay. Huh. No, hold on. It'd be
Pause.
You don't have to hold it up to your.
Okay.
Like if you just sit on the desk, it'll.
Okay. So, and
I know what we're going to do. This is A squared, and then we have to figure out B squared, right? And then C squared. But we have to subtract. We're looking for A squared, right?
yes.
The problem is we can't. 2BC. Okay. We have to figure out why, right?
Mm.
To figure out.
We're gonna pause because these two groups whose work I love. Two groups in here, maybe three. I'm not listening to you guys. We need a cosine of A in here somewhere, right?
Mm-hmm.
I mean,
Yes.
we do at the end. 100%. How do you get the cosine of A out of your picture? What is the cosine of A? Could you solve that for something else?
Yes.
Like, you can solve it for X or B, I think, right?
Mhm.
I would use that. I like that jumping in point. I like that one. I would carry on.
Okay.
We might have to go back. Hold on.
So we got just told some very important information by Mr. Holloway. So we are gonna use a suggestion.
Okay, let's see. Cos A would be. The cosine A would be. X would be X over B, right? X over B, right?
And now
Multiplied by
we should find
B.
which one it equals. We should
All right. So
I like what you've done there, Addison. I like that approach. X, you now have a nice.
hold this.
I bet there's a nice way to write another pretty common variable.
let's see.
Maybe. I mean, like you could do the same thing as B, right?
B squared would be.
Try.
x squared plus y squared. Are you looking? Can you look and check what they're doing?
There's another formula that we use from the Pythagorean theorem that shows up more commonly on coordinate planes. The Pythagorean theorem works really well for floating out in space, which we certainly have to use it. But there's another thing that comes out of the Pythagorean theorem on coordinate planes. Well, we don't need the coordinate plane there if you're talking to me. But gosh, if I like a squared is just the square of the distance a, right?
Mm-hmm.
Well, Pythagorean theorem leads us to a way to find distances. I think. So I'm just throwing it out there. I've been spinning around. I'm just going to say it. I think the distance formula is almost the same thing as Pythagorean theorem. Just tossing it out there.
Okay, we're gonna find a by distance formula. Distance formula is square root of.
How do you remember this? Oh my god.
It'd be x2. It'd be x sub 1 minus x sub 2 squared plus or minus.
I think I have no clue. Is it plus or minus?
I don't know. We'll figure out y sub 1 minus y sub 2. Let's see, is it minus?
I don't know.
Can you figure it out? Ask
I don't-
somebody?
I don't. You're making me mad. Where would I find the information about that?
Christine, can you look? I can't.
I'm gonna smack you. Shut up.
Unhelpful.
Plus.
Plus, okay. Thank you. Let's see, that would be, we'd have x minus c squared plus y minus 0. So that'd be, this would just be y squared. And x minus c squared,
You just keep it as that?
Hmm?
Would you just keep it at that, or would you just unsquare?
No, we can't do that.
No?
I don't think so. Let's see. Because they're being added. You can only do that if. I don't know if you can break it apart if they're being added. I don't think you can.
So
X minus c.
So x. Oh, we have to expand. Do we expand it or no?
Huh?
Do you want to expand it?
I don't know.
Okay. But I don't get what they're doing.
We have x minus c. That's that'd be x squared, and that'd be x c negative. That'd be negative cx, and that'd be c squared. We'd have x squared minus 2x c plus c squared. A lot of squares. Can you look over this? Can you look? You're the one standing.
It's just y. Which maybe that won't help right now, but I like you're getting closer to here, just with what you had. Let's see.
I don't know what's happening at all.
C is equal to C.
I don't know.
What do you think? We'll just talk over.
I have no clue.
So x minus c. So don't forget you still have the square root of it.
Yes.
I want you to try something. Keep it x minus c squared. Plus y squared. Now we have a way to talk about some x's and some stuff already. I think we don't have it yet. if we need a cosine of A, like we have to have a way to get it right. What's cosine of A?
X over B.
So what's X? And like you should write this out. Cosine of A is X over B. You said.
Yeah.
And I'm okay with that. And then, what happened if you solved it for X? X equals
-2cx.
You're going too far. Will you do me a favor just down here next to where you're working? Will you write X equal or cosine of A equals X over B? And you're gonna see something immediately.
Equals X over B.
And now on that line that you're looking at, there we go. Well, don't you have an X right here?
Yes, we have an X.
And then you just found something that can go into it.
Let's see.
Like let's
B cos A minus C 2 plus y squared is what he's asking, I guess. You have I don't know why he's leading us to is the problem. Like, am I supposed to? Cause do we square it and we have B.
Lord have mercy.
Hold on.
I'm giving you time. I'm thinking to myself and saying it out loud.
Why did we draw a line?
Hmm?
Why did we draw a line?
I hate this.
You guys are getting.
I hate this. I genuinely hate this.
Why is the high heat?
Yeah. Tell me more about it.
Huh?
Tell me more about it.
I
I don't know anything more.
F of C squared. B squared would be X plus Y squared.
I like that thought.
B squared would be.
Can you write it?
Can you stop?
Can I write?
No.
Taking so long. Chrissy, you can also do it on the board behind you too.
No, she's just writing too slow for my liking.
Okay.
You.
What did you do?
Come back together.
I don't know at this point. At this point, it's just like B squared is it's X squared plus Y squared. It's like right over here.
Okay. Can you write that? I'll let you know. Like someone else. Okay.
I'm gonna tweak out on this thing.
You want me to write?
Yes. Because at this, shut up.
Okay. Nice. Nice.
No, you won't.
Okay.
Yes. Okay. Tell me, Karina, what you said.
Something about B squared equals what?
B squared equals what?
What is it equal?
B squared equals X and Y squared?
Great.
Okay.
What theorem was that?
Pythagorean theorem.
Can you use that anywhere else?
Mm.
You can only use those when you have what type of triangle?
Right triangles.
Okay.
So, and obviously, A squared is.
Last decision. You want to keep going till the end of the hour? We got 6 minutes left. Okay, let's start a class tomorrow. We will prove this together. The first one, if a group gets it, I will buy you some candy at the store to go home at lunch. If a group gets it and you can explain it to me or the class, I will buy you some goodies at lunch.
Okay,
Cool.
this was the equation that he was saying.
It's just like, why are we pulling out random stuff?
Karina, you can do it. It's fine. Oh my god!
Keep going.
I have an idea. Wait, pause.
Just rearrange it.
minus.
Plus X squared. 2cx
What? Think about it. I can read something.
plus x squared, right?
So these cancel out.
Yes.
Okay, we're close. We have 2bc. We're missing the 2bc times cos A. Okay, tell me what to write then.
Okay, so you have a squared, right? We have no, stop.
Krina, tell me.
It's b squared. Do you see a squared up here, right?
You know, just point at me, Krina. Just point. I'm trying. I can't remember this part right now. Just tell me what to point. Tell me.
B squared minus 2cx, right?
Yes.
Equals 2.
You're losing me. What?
A squared equals. Equals, right? Remember how we said cosine A was x over b?
Yes.
And if you have 2bc by x over b, b's cancel out. 2cx, right?
Yes.
So you
Oh, wait. I get it.
Yeah.
Okay, can you go get him? I'm trying to show the steps. I'm. Can you just quit? Okay.
This is so messy. I need it rewritten.
Okay, hold on. I erased this. Do the work here. Sorry, we're gonna see if I can. I'm gonna see if I can clean this up. There you go. We have
Stop. Pause.
Another group already got it.
Huh?
Another group got it first.
Really?
But
Dang, I'm happy just I got in the first place because she.
Oh, we did not need to do the distance
No,
formula.
you didn't.
So this you guys can see, and whether it's just a formula Pythagorean theorem, I want you to know the same thing. So if you use Pythagorean theorem, you did use distance. It's just 0, 0. This is as nice and organized as it can be.
Oh wow.
That's all it takes.
Lord have mercy.
And we'll get that one in our notes, just so
Okay.
you guys know. But it's awesome that you guys got it. We're gonna see if we get it. What do you guys think? How we doing? Where'd you 20? Oh, it's 2cx.
Yes, b squared equals x plus y squared. Y squared plus c minus x squared. C minus x squared.
What do you mean C? Like what?
Or just writing this on the board.
That'd be b squared minus x squared plus c.
So essentially, what we did, if we're gonna look specifically at the math, we found what b squared and a squared was. And essentially, we kind of found what y was so we can replace y in the a squared formula. So this is what it looks like when we substitute y squared as b squared minus x squared. So here's a squared with that substitution plus c minus x squared. And so we expand it. So we expanded it. And then after that, we simplified it to the as far as we can go. Now, this work up here shows what negative 2cx is, because essentially what cos A is x over b. And if it's multiplying by negative 2bc, then the b's cancel out and it goes to negative 2cx. And because of that, then we can substitute it and put b squared plus c squared minus 2bc times cos A.
All right, guys, 60 seconds.
Yay! I think you are. No. I have a name. It starts with an A.
It's Christina.
There's a name. It starts with an A. I love you. But Christina, I'm looking. Spectacularly, bioswale, hydroponically, indubitably.
super easy if I walk you through it.
Hey, I know what this word. Indubitably. Do you remember that word when we watched what's it called? I don't remember. We watched this. Oh, you looked at the no.
It is not.
The name of the house with the clock in its
Like
walls.
a
Oh my god, I
Raiders.
remember that movie. That was so annoying.
Red, Aisha, and Casey. What do you want to bring him on?
Can we tell you by then?
Sure. Do that. Did you guys get it?
We like found the different paths to do it stuff. Does that still count?
We should be able to, yeah.
No.
If I got it. I'm sorry. No. Yep. I just went in and filled it. I saw a blank assignment and I knew that we had it. So I just marked 5, but it's at 10. Yep, I'll fix it right now. Thanks, guys.